So let's do problem 20. So this one's about exponential growth. Don't be freaked out that I said density instead of like population size. I'm assuming that the broth culture here isn't growing in size over time. It's a fixed amount of broth. So changes in density are exactly the same as changes in population size. So here's what we know. It says that it is growing exponentially. So the general model for exponential growth is that where y is whatever it is that's growing. This is the initial size of the thing. R is the growth rate, and t is time. All right, so we need some way of getting the information in here so we can solve for these two parts. Because if we knew what p and r were, then we would have an equation where you could just plug in time and you would get out the density, what you want. So that's our new goal. Our new goal is to figure out what are p and r. All right, it says the density was 4,300 individuals per milliliter 2 hours ago. All right, so 4,300 milliliters per individuals per milliliter. P, e to the r. So 2 hours ago. If we want to count now as time 0, then 2 hours ago would be t is -2, assuming I'm measuring time in hours. All right, well, that's one equation. Let's get the other information in there. It's now at this density. So 5850. So if this is now corresponds to a time of 0, so I'll plug in 0 for time. This immediately just simplifies because r times 0 is 0, and e to the 0 is 1, because raise anything to a 0 exponent, you get 1. So this just tells me what the initial population is, which sort of makes sense because initial population means your population when time is 0, and we just set it up so that I plugged in 0 for time. Okay, well, so far so good. So that means I can plug this value in for p in the other equation. So 4,300 equals 5850 times e to the r times -2. And now you can see I can very easily solve for the r value. If I divide both sides by this and then take the natural logarithm, I've got natural log 4,300 over 5850 equals -2r. Just divide by -2 on both sides. And now I've got my r value. And you could use a calculator to figure out what that was. Okay, so let's back up, because problem solving, especially in calculus, the problems can be fairly lengthy, so you don't want to get lost in what is your solving procedure. So we got this equation originally because we knew it was an exponential growth model. And we knew we were trying to find p and r, because if we only knew what those constants were, we could plug in a time and get an answer. And that's what the question is asking. It's saying, what's the density at a certain time? So all of this plugging in the other information was we're trying to solve for p and r, and now we've done it. So rewrite your original equation, y equals p times e to the rt, only now substitute in the particular values that you know for r and t. The end of the question says, what's the density 4 hours and 15 minutes ago? Well, since now is time 0, 4 hours 15 minutes ago must be a time of -4.25, because 15 minutes is a quarter of an hour. So all you do is you already know what p is, you already know what r is, just plug in -4.25 as your time value, and your equation will tell you what the density is, and you've solved the problem. Good luck!